Good day, Grade 9s, and welcome to our Grade 9 Natural Science Worksheet Cloud lesson. If you have a question during the lesson, send an email with your question to grade9@worksheetcloud.com. My name is Mrs. Ernston, and I'm the Worksheet Cloud Grade 9 Natural Sciences teacher. I hope you have pen and paper ready to take notes as we work through today's lesson. And I just want to say how absolutely delighted I am that you joined us today, and I'm looking forward to interacting and teaching and learning with you in today's lesson. So prior knowledge that is beneficial to having covered for this lesson, but it's not essential, is general knowledge on acids, bases, pH, and neutralization. So it would be helpful if you know what the reaction between an acid and a base is called, and that is known as a neutralization reaction. What happens to the pH when an acid and a base are mixed? Does the reaction between an acid and a base always give a neutral mixture? So in other words, is it always a pH 7? And what factors will determine the pH of the final solution when an acid and a base are mixed? So we're going to be focusing on metal hydroxides and how they react with acids. So a metal hydroxide forms a basic solution when it is dissolved in water. So have you ever tried this? Make a cup of tea with no milk and no sugar, and add some lemon juice bit by bit. What happens to the color of the tea? Well, here is our tea that we made without any milk or sugar, and it doesn't matter whether you use robust tea or normal tea. Any tea leaves should be fine. And this is what color the tea looks like after you've added some lemon juice. So another thing that is also important that you have covered in grade 9 are the different types of indicators that we have and knowledge of how they change color in acidic or basic or neutral solutions. So red cabbage water, red onion water, and turmeric are all indicators that you are able to make at home. Phenolphthalein, bromothymol blue, red and blue litmus paper, and universal indicator you will find in general school laboratories. And we will have a look at some of these indicators as part of our lesson today. So it is a general requirement that for grade 9, you learn these indicators, you learn what color they turn in an acid, which is an aqueous solution with a pH 1 to 7, what color they are when the solution is neutral, that's pH 7, and what color they are in a base, and that's pH 8 to 14. So universal indicators can have many different colors, from red for strong acids to dark purple for strong bases. The liquid inside the middle test tube is neutral pH 7, and this is shown by the green color of the indicator. So today's lesson is going to focus on the reaction of acids with compounds to form basic solutions, and we are going to focus on metal hydroxides. So a metal hydroxide forms a basic solution in water. So that means an aqueous solution of a metal hydroxide will have a pH value above 7. When a metal hydroxide reacts with an acid, a salt and water form as products. And the general word equation is an acid plus a metal hydroxide react to form a salt plus water. If we have a look at the periodic table, these are the elements that we are going to have a look at in today's lesson. We're going to have a look at oxygen, hydrogen, and chlorine, and these are all non-metals. So hydrogen we represent with a capital H, oxygen we represent with a capital O, and chlorine we represent with a capital C and lowercase l. The metal we are going to have a look at this lesson is sodium, that we represent with a capital N and a lowercase a. So the general equation for the reaction of an acid and a metal oxide is an acid plus a base reacts to form a salt plus water. But since the base in our reaction, and the base we're referring to, is a metal oxide, we can rewrite this generalized neutralization reaction as acid plus metal hydroxide reacts to give us a salt plus water. So this is the general word equation for the reaction between an acid and a metal hydroxide. If we look at the salt, the type of salt that forms will depend specifically on the metal in the metal hydroxide that we used for this reaction.
In the double displacement reaction of an acid with a hydroxide, we'll react hydrochloric acid with sodium hydroxide. The two solutions are colorless, so it's difficult to see what is happening. The acid-base indicator is bromethymol blue, which is yellow in acid and blue in base. As we add the sodium hydroxide solution, the indicator changes from yellow to blue as the solution changes from acidic to basic. Sodium chloride and water are produced in the reaction.
So an acid-base reaction is an exchange reaction. And at the bottom of the screen, I've just put the word equation for you to refer to. So that is hydrochloric acid plus sodium hydroxide reacts to give us sodium chloride and water. The acid-base reaction we'll be looking at is an acid plus a metal hydroxide gives us a salt plus water. And here we have examples of our exchange reaction. So we have a penguin that we represent with letter A. And the penguin is wearing a hat that we represent with letter B. So the first compound we refer to as AB. And then we have a pig that we represent with letter C, and we have spectacles that we represent with letter D. Then we have the arrow that represents a chemical reaction has happened. And now we move on to our products. We have our penguin that is still labeled letter A, but there has been an exchange reaction between the penguin and the pig. Because as our products, we still have a pig that is represented with letter C. but the penguin and the pig have swapped accessories. The penguin swapped the hat for the spectacles, and the pig swapped the spectacles for the hat. So in our new equation, we can represent AB represents HCl, that is our acid. CD represents NaOH, that is our metal hydroxide. AD represents the salt, NaCl, and CB represents the water. So in this reaction, if we have a look at the acid, the hydrogen in the acid went to making water. The chlorine in the acid, HCl, went to making the salt. If we have a look at our metal hydroxide, NaOH, the sodium in our reactants went to making the salt in our products, and the hydroxyl group, OH, went to making water. So we don't write water as HOH. We write water as H2O. So if you can just remember that the one H came from the acid and the other H came from the hydroxide. So in this reaction, our acid and our metal hydroxide are reactants, and they react together to form a salt and a water. And this is known as an exchange reaction. So what I would like you to do now is pause the video and see if you are able to re-explain what is happening in this diagram, or you can pause the video and just make some notes about your understanding of the acid-base reaction. Okay, just a reminder that the acid contributes the H towards making the water molecule. The base contributes the OH towards making the water molecule, and whatever is left of the acid and the base after making the water molecule becomes the salt. Then just to revisit chemical equations, when we have a look at a chemical equation reaction, we can represent that using symbols from the periodic table. So in this reaction here, the H represents hydrogen, plus oxygen is represented by O, and H2O represents water. The numbers in front of the letters are known as the coefficients, and they represent the number of molecules in the reaction. The subscripts at the bottom represent the number of atoms of each element that are part of that reaction. This arrow represents a chemical reaction. Everything to the left of the arrow is known as the reactants, and everything to the right of the arrow is known as the product. And this is very important to know when learning to balance chemical equations. So when balancing chemical equations, please remember that you are not allowed to change or alter the subscripts. You're not allowed to change the number of atoms that we find within the elements or within the compounds of the reactants and products. The only thing that you are allowed to change is the coefficients, or the number of molecules. In an instance of this yellow block here, or this blue block here, that just represents invisible 1. So the yellow block is just representative of 1 molecule of oxygen, and this here is just representative of 1 atom of oxygen in a molecule of water. So in the reaction that we've had a look at now, the hydrochloric acid and the sodium hydroxide are known as reactants, and the sodium chloride and the water are known as the products. This is the chemical equation reaction. So hydrochloric acid is HCl, sodium hydroxide is NaOH, sodium chloride is NaCl, and water is H2O. And now what we need to do is we need to check whether or not this equation is balanced. So if we have a look at our reactants, we write down the names of the elements. So we have hydrogen, chlorine, sodium, and oxygen. And in the reactants here we have 1 hydrogen, and here we have another hydrogen. So there are 2 atoms of hydrogen that are reacting. We have 1 atom of chlorine, 1 atom of sodium, and 1 atom of oxygen. So that forms our atoms that make up our reactants. Let's have a look at our atoms that make up our products. We have hydrogen, chlorine, sodium, and oxygen. We have 2 atoms of hydrogen, 1 atom of chlorine, 1 atom of sodium, and 1 atom of oxygen. So when we have a look at the hydrogen between the reactants and the products, there's 2 atoms on either side, therefore it's balanced. There's 1 atom of chlorine on either side, therefore chlorine is balanced. There's 1 atom of sodium on either side, and there's 1 atom of oxygen. So that means that this equation is balanced. So I would like you to write down 5 questions related to what you have learned today. And each question must start with a different word. What, who, when, where, why, how. And you can really challenge yourself by asking a question, what would happen if? So we're going to have a 3, 2, 1 activity just to recap everything that you have learned today. So I would like you to write down 3 things that you have discovered in today's lesson, 2 facts or details that you found interesting, and 1 question that you may have. If you are unable to find the answer to this question, or you have any questions for today's lesson, please can you email your questions to grade9@worksheetcloud.com. So thanks for watching grade 9s. It was super to show you some of these experiments, and I hope you saw a lot of fun, exciting things. Those color changes were very, very interesting. And I'd also like to thank WorksheetCloud for bringing this lesson to you. Goodbye, grade 9s.